Right, so guys, welcome to another session. So last week, those who were here, we did some complex calculations on pressure enthalpy diagrams and COP and mass flow rate, and I did it. I've emailed to everyone that were here the handout and also the link to the video. I'm hopeful you've got access to that. Okay, and want to move that forward. One thing I do want to say that we're nearing towards the end of the year, I must admit, and I want to let you know that the last session I'm proposing to do is on my birthday, which will be the 18th of December. Okay,
Hmm.
it's a Thursday before Christmas Day, basically. So it's a week. Well, I was born a week before Christmas, 18th of December. So that'll be our last session here. Uh, then I might do the Saturday on the 20th. I'll have to see, have a look at that. But certainly that'll be our last session. And then in the new year, I'll probably pick up something like the first. It might be the 7th of January, something like that. 7th of
Hmm.
April. So actually, it'll be the 8th of January, the Thursday, because obviously January the 1st is New Year's Day. So we're saying 8th of January. Okay. So 18th of the 12th last time, and then 08. I'll send this in an email, 26. And then Sean and Gareth, you're coming down to my place on the 10th of January, yes? That'll be Sean and Gareth. Okay.
Sorry, I'm muted. Yeah, 10 for Jan.
Yeah, 10th of Jan. Okay.
Yeah.
Now, I must admit that where I'm at the moment is I'm at home, obviously. But what I've been thinking of, it seems to be that I'm getting two distinct groups now, in the sense that we've got a group of all new starters, okay, new starters, and I've got some of you say more mature ones, more experienced ones. So what I'm planning to do, I've been talking to a colleague of mine, Neil McCourt. He did the level three with us on a Tuesday, and he's keen to get involved. So what we're looking to do is probably split the group into two. We have the new starters, like first years, and then the other lads stay with me for the second year stuff, and
Hmm.
that will probably work better. So that I'll still be in command, obviously, still available, and we'll probably run the two, simultaneously. Except Neil will be he's actually in India at the moment. I envy him sunbathing in Goa. He's a very very good lad. So that's on the card, and we'll probably start that next week, and but we'll have a group session together on that to make sure that happens. Because obviously I'm conscious of the fact that I don't want to keep repeating the stuff that I've done before for the older lads, and also I don't want to make it overcomplicated for the new lads. That will be a fair scenario on that.
Hmm.
Does anybody have any issues about or concerns about that at the moment? Just a discussion, really.
No, that's fine.
Yeah, I'm thinking people like we've got Sam, we've got Adnan, Joe's not there, probably Oliver as well. The new starters who started recently. Um, move you to Neil. He'll take over and teaching and Zoom and stuff like that, and then I'll continue. But we might mix and match it as well with joint stuff to be done. So that's
Hmm.
moving things into the future. I am conscious of the fact that people like Will and Darren won't be here either, and the Braywell lad. I'm supposed to be inviting you on a Friday. If I'm honest, I've struggled at the moment through not through wanting to do it, just busy. A with my health not being too well, but also busy at work. So I'm thinking there's two strands. In the new year, I'm going to get some firm dates out for a Friday and talk to your employers to get that back on track. But also, I want to be looking at trying to get you in, some of you, on block release if I can. But I'll talk to your employers. Obviously,
Hmm.
Sean, you're coming on a Saturday. And those lads that are doing the NVQ, which is in here, we got Sean, the two lads, Owen and Liam from BRS. I might want to try and do some on-site assessments. Sean, I might try, Sean, before Christmas, just come down to London to see you if I can get onto site to do an on-site assessment. You're on mute, Sean. You think I won't get on?
You won't get on interaction. It's hard enough to get our lads on.
Right, okay.
It's a server room that runs the Bank of England and all that. So
Right,
it's
okay. Well, we can have a look at that. I mean, obviously
we
we
have
need to
sites all over the
on-site
UK. We
assessment,
do a
don't
lot of the fire stations. We just took a load of BMW garages on, all
we?
the
Right,
showrooms.
okay. Uh-huh.
So we're doing big installs on them coming up. We've got a huge one.
Right, okay.
The fire departments all over the country.
Uh-huh. Okay.
So
I'm trying to increase the volume. I don't want to. Okay, right. Someone's just trying to get in. Okay, are you all in? Okay. Harry, are you there?
Yeah, Paul, I'm here.
Good to see you. Okay. Okay, so we got Adnan, Harry, Oliver, Sam, Sean, Will. Okay, right. What I want to do is I want to pick up on the handout that I started, well, we looked at last time. So you should have all received this. Okay. So briefly, I'm not going to do the whole lot again, but we're just looking here, pressure enthalpy diagrams and enthalpy, refrigeration effect, heat of compression, condensing effect. Then we're looking at the capacities, mass flow rates, times heat of compression and stuff. It's this formula that eventually you'll need to understand and be able to apply for the online tests. And then I went into compression ratio. So pressure ratio, compression ratio, it's absolute discharge pressure divided by absolute suction pressure. And we did some examples. And then we also looked at using the temperature and the entropy, well, the temperature in particular. So looking at this one here, we said, look, we've got the suction pressure that relates to an evaporating temperature. We've got the discharge pressure, which relates to a condensing temperature. And converting those to absolutes, we can actually work out the COPR and the COPH. So on this one here, we've got evaporating temperature minus 4.54, add 273 to give it 268.46, and then discharge, so condensing temperature 36 plus 273 is 30. Okay, and that gives us 309. And then if we're looking at COPR, okay, COPR, T1 divided by T2 minus T1. So the evaporating temperature is 268.46 on the Kelvin scale. And you divide that by the difference, 309 minus 268.48, and that actually mathematically comes out at 6.6 to 1. So the COPR refrigeration is 6.6 to 1. And then COPH, we've got the situation where that's 7.6 to 1. And how we get that, we say T2, which is condensing temperature, divided by T2 minus T1, which is 309 divided by 40.54, which is 7.6 to 1. So these should marry up in the sense that COPR plus 1 is your COPH. Okay, so I'm just going to concentrate. So just going to, I'll put the date here, 20th of the 11th, 25. And so let's say that we've got I'll do it color. Okay, we've got evaporating temp. Okay. Right, we're saying evaporating temperature Okay, let's say that's at 0 degrees C. Okay, there. So I'll change this to blue. Okay. And if we add 273, that's going to give us 273 Kelvin. 273 Kelvin. And then if we set the discharge temperature, condensing temperature. Condensing temperature, that's at, let me just get Liam involved. Okay. Hi, Liam.
Yeah, all right, Paul. Sorry,
Yeah, I'm
mate.
good, thanks. You okay yourself?
Yeah, sorry, mate. I was doing something.
Okay, not to worry. I'm just going to continue, Liam, with the calculation that we did last week. And we did T1 divided by T2 minus T1 to get the COP. So we've got an example here. Evaporating temperature is at 0. At 273, it's 273 Kelvin. And if we've got the condensing temperature at 40,
Yeah.
we add 273 to it. Okay, and that gives us 313 Kelvin. Okay. Hi, Jamal. Jamal, you okay?
Yes, hello, Paul. Sorry, I keep having trouble joining your links. I don't know why. Sometimes I
I have problems every week joining it. Every single week. Yeah.
Is that because of the web?
I have to type it in manually. I've learned that now. Yeah. Every week
I'll have to look at why, because normally I'm not on the receiving end of what I'm sending out, but we can have.
It works for Gaz. Gaz, it told me he just clicks on it, but when I do, it just will not have it.
Yeah, it works for me as well. I just press on it and it loads.
Yeah. Okay, so what we're saying is here. Hi, Owen.
Hi, Paul. Sorry about being late.
No, that's fine. So we're just continuing on doing another example of COPR, COPS using T1 and T2.
Yep.
So we got here evaporating temperature is 0 plus 273. That gives us 273. And the condensing temperature, 40 plus 273 is 313. And then if we're looking at COPR, okay, COPR, we're saying COP refrigeration, that's going to be T1 divided by T2 minus T1. Okay. So we've got a situation where here we're saying, okay, T1 is 273, and divided by 313 minus the 273. 273. Hold on, sorry. Yeah, that's right. And then, so that's going to give us basically 273 divided by 40. Okay, 40. And if we do the maths on that, we're saying 270. Sorry. So if we just do the calcs, okay, it's 273 divided by 40. Okay. And that gives us 6.825. So that's 6.825 to 1. Okay. To 1. Now, knowing that the COPR is 6.825 to 1, if I just change my pen to red, right? So COPH, what would that be then, without doing any calculation from knowledge? So we've got COPR 6.825 to 1. Then your COPH, what would that be? Any thoughts? Okay. So what that will be, it'll be COPR plus 1. Okay. So that basically is going to be, I'll change the color. Let me just change this to blue. Okay. So we're saying, look, it's 6.825 plus the 1, okay, which equals 7.8. 7.825 to 1. Okay, right. So, and that's using a temperature scenario. What I do want to try and do, not try, is to have ensure that you know what that means. Okay. So what does this mean? This is a revisor, and what this means. Okay. Right. So what this means is, if let's say we got imagine we got a 1 kilowatt compressor. Okay. 1 kilowatt compressor. I'll just put that in black. So in that case, what's going to happen if if you're looking at this one here, COPR at 6.825, it means 1 kilowatt compressor gives, it's going to give 6.825 kilowatts of cooling. And 1 kilowatt compressor is going to gives okay, on heating or the condenser side, it's going to give us 7.825 kilowatts of heating. Okay. Right, does that make sense? So what I'm saying is, you've got 1 kilowatt compressor, because the COPR is 6.825 to 1. A 1 kilowatt compressor gives us 6.825 kilowatts of cooling and 7.825 kilowatts of heating. Now, if that compressor is double, let's say it's 2 kilowatts, it's going to double that. If it's 3 kilowatts, it's 3 times. It's a ratio. Okay. Now, and I want to show you that efficiency. So that's an efficiency. So we're getting 6.825 to 1 and 7.85 to 1. If I give you a comparison, just to drive it home as a revision, as a discussion, okay, right. If we consider an electric heater, okay, an electric heater, okay, rated at 1 kilowatt, okay, will give 1 kilowatt of heating. Okay. Yeah, electric rated at 1 kilowatt will give. So you got 1 kilowatt going into it, and you got 1 kilowatt coming out of it. Okay. And what we're saying here is we got a compressor that's 1 kilowatt rated, and because of the air conditioning cycle, we actually get 7.825 kilowatts of heating out of it. So it's 7.825 times more efficient. Okay. And I want to take this a bit further, particularly with heat pumps around and stuff like that. Now, if we consider a gas boiler, okay, and I'm going to be asking the gas boiler guys. So a gas boiler, okay, gas boiler has an efficiency what kind of efficiency do we get out of a gas boiler, percentage-wise? Any thoughts?
20%.
20%, 20% efficient, or you're losing 20%?
Losing
20%. So what's Willie's saying is that the gas bore efficiency of approximately 80%. Okay. 80%. Okay. Now, what that means, okay, this means that if we put in 1 kilowatt, okay, put in 1 kilowatt, we actually get
0.8.
correct 0.8 kilowatts. Yeah. So you can see if you look at gas-fired boilers, then because their efficiency is less than 1, they're very inefficient. Yeah. So that's 0.8 efficient. So we're putting in 1 kilowatt, and we're only getting out 80% of that. And if it's 2 kilowatt rated, we get double that, 1.6 for 2. So that gets less and less. Now, a typical question on the diploma might be, okay, let's say that we have, okay, let me just write this. Right. Question. We have a heat pump rated with a COPH of 4:1. Okay, 4:1. How much more efficient is it than a gas boiler rated at 80% efficiency? Okay, that's what we're looking at. Okay. So any thoughts on that?
320%.
How many?
320%.
320%. Let's have a look at that. So I'll just put this in here. Okay. So 320%. Okay. I'll just put that there for now. Okay. Right. So if we look at it, okay, what we're saying is, so, right, if we wanted to, right, so we got 0.8, okay, 0.8 efficiency with a boiler. And we got basically we got 400% efficiency of a heat pump. Heat pump. So what we're saying is really that's 0.8. You could say that's if we looked at so to get 1 kilowatt, okay, to get 1 kilowatt, to get 1 kilowatt of heating from a boiler, okay, we need to put in, right. So what I'm saying is, if I put in 1 kilowatt, I'm only going to get 0.88. Okay, so we need to put in basically something like 1.25 kilowatt to get 1 kilowatt. Approximately. Okay. In fact, you could probably 1.2. Okay, it's going to be, yeah, you can do that 1.2 because 20%. Okay. So that's 20% basically. So what we're saying is we need to put in 1.2 kilowatts to get 1 kilowatt out, and here we're putting in 1 kilowatt to get 4 kilowatt out. So comparing it, we're saying we need to put in, okay, we got 4. That's 4. That's for the heat pump, and then we're going to have to go back towards basically 1.25, 1.25, 1.2, sorry. So what we're saying is, if you're looking at 1 here, we have to put in 4 to get 1 kilowatt is going to give us 4 kilowatts of heating on the refrigeration cycle condenser, but to get 1 kilowatt of heat out of a boiler, we have to put in 1.2 kilowatts. So the result is that the actual heat pump is 5.2 times more efficient. Let's just think about that. Okay. Will, do you agree with that, Will? Approximately? Or not? So Will. Okay. Oh, he's gone. Okay. Right. Sam? Does that make sense to you?
Paul,
Kinda.
oh.
Kinda.
Yeah. So what we're saying, basically, we're saying, look, with a heat pump, to the lads, yeah, we're putting in 1 kilowatt, we're getting 4 kilowatt there here. Okay. And what we're saying is, for the boiler, okay, so he was saying, look, to get with one, we're putting 1 kilowatts to put in 4 to get 4 kilowatts out. You know, COP of 4 to 1. And to get 1 kilowatt of heating from a boiler, we have to put in 1.25. Okay, so sorry, 1.2. So 4 plus the 1.2 gives us 5.2.
Paul, I have a question. You know,
Yes.
I said 320%. Is that still wrong?
Yeah, because what I'm saying is it's not wrong. In fact, the correct answer is 520%. Yeah.
Yeah.
That 5.2. Yeah. So what I'm saying, really, if you're looking at it from that point of view, the actual efficiency overall, it's compared to a gas boiler, is that? Yeah, 5.2 to 1. So we're putting in 1 kilowatt Okay, and that's going to give us 1.2 kilowatts from the boiler plus the 4 that we get from the aircon unit, heat pump unit. So that's how efficient that system is. Or if we're comparing the heat pump to the gas boiler,
Paul, why do you add it instead of minus it? That's why I don't understand.
difference. It's a difference. Yeah. Well, so with the heat pump, we're putting in 1 kilowatt. We're putting in 1 kilowatt to get 4 kilowatts out. That's positive. Whereas on the heating side, on a gas boiler, if I put in 1 kilowatt, I'm only going to get 0.8. I'm only going to get 0.8 of a kilowatt out. So to make it balanced, to get 1 kilowatt out with a gas boiler, I'm actually going to have to put in 1.25 kilowatts or 1.2 kilowatts.
Okay.
Because of the losses. So we're saying that in a boiler, we're putting in 1.2 to get 1 out.
Yeah.
As Will said earlier, we're losing 20%. So that 20% is actually wasting energy. Okay. So if we're looking at this, so we got gas is the least efficient. Gas is the least efficient. That's only 0.8 efficiency. Then we got electric heater, and that's a COP of 1 to 1. Okay, so this could be. I'll just write this here. So COP heating. Okay, that's going to equal 1 to 1. Yeah, we're putting in 1 kilowatt and we're getting 1 kilowatt out. Okay, putting 1 kilowatt and getting 1 kilowatt out. On a heat pump, we're putting in 1 kilowatt, and we're getting 4 kilowatts out. But with a gas boiler, we're putting in 1 kilowatt, but we're only getting 0.8 of a kilowatt out. Okay? So that's the scenario there. So here we're getting 5.2. I'll just move this down. So the difference is it's actually 5.2. That should be 2. It's going to be 5.2 plus 1.2. So it's 5.2 times more efficient. 5.2 to 1. Right. Okay. Question 2 then. That was A. Or question B, sorry. Okay. So it's saying boiler. Boiler is 70%. 70% efficient. Okay. We have a heat pump. A heat pump whose COPH is 7 to 1. 7 to 1. Okay. So my question is, how more efficient, or sorry, not how more efficient. Okay. Yeah, how efficient is the heat pump? Heat pump as compared with the gas boiler. Okay. So basically what we're saying is, look, that's 70% efficient. So it's going to be with a boiler, okay, it's going to be at, we're going to have to put in 1 point.
Is it 8.3 or something?
Yeah, you're right, 8.3. So boiler is going to be 1.8, 1.3 plus whatever the efficiency of the COP of the heat pump is, which is 7. So that's going to be 8.3. 8.3. So this heat pump is 8.3 times more efficient than the boiler because it's got a COPH of 7.
Well, what do you do if they're both positive efficiencies?
You won't get a boiler that's more than 100% efficient.
Will you not get a question like that? No.
No.
Oh, that's fine.
Yeah. Now it's really taken into consideration, Jamal, that we get an efficiency of less than 1, and then with the COPH, we're getting a positive COP. And really, it's looking at the difference between two numbers. Okay.
Yeah.
Right. Let me just stop that there. Right. What I want to do is I want to get involved. I just need to go into the net. Okay. Right. Right. I'm going to look at a masterclass on heat pumps for us. So if we go into ior.org.uk, which is the Institute of Refrigeration. Sure, and I'll email Ella again. All right. Right.
I've had an email.
What did you say?
Apologies.
Okay. Right. Yeah.
Yeah, and then I got an email today of someone else called
Natalie. Yeah?
Mm.
Okay. So when we get into onto the IR website, we got these master classes. You know, I have mentioned them to my group previously, and then here we got a whole host of a library of talks. You know, compressors, correct sizing of air-cooled condenser and air-cooled chillers.
Paul, I just want to say you're not sharing your screen if that's what you intended.
I did. That's what I did intend. Thank you, Owen, for allowing me to know that. Right, let's try again then. Right. Thank you, Owen. Okay, so right. So for example, here we got understanding refrigeration efficiency. That's a good one. Actually, that's and then we've got heat pumps on that one, and how a heat pump works, and then a case study servicing a domestic heat pump. Will, what do you get involved in? What are the commercial heat pumps?
Industrial big ones really.
Right, okay.
Providing heating and cooling for air handling units.
Oh, brilliant. Okay, let me just I won't do this one. I want to get rid of this one. That's not the one I wanted. Okay, right. What I wanted to have a look at really was let me look at. I want to look at efficiency. Okay, so understanding refrigeration efficiency. Just want to pull this one out. But just tell me, sometimes the volume doesn't work on this. So just let me know. Okay, Jeff, will you tell me if you can hear the volume? Because I can hear it on my screen, you see. But just...
No, I can't hear anything as yet.
Nothing's coming. Now?
Nope.
Could you hear that? Chaps, could you hear that?
No, can't hear anything, Paul.
Now?
Nope.
No.
No? No?
Nothing.
Can't hear anything. Okay.
Nah, I can't hear anything, Paul.
All right. Okay. I can. I must admit. So, okay.
So the email was of Alexander Malcolm, Paul.
Right. Okay. Okay. Let me just stop this, and that's not going to work. Okay. Okay. Right, just going to stop that. It says set up audio settings. I think with these master classes, you have to get onto them yourselves. Now, this is what I want to. Whilst I'm here, I wanted to remind me, Sean. You got membership, haven't you, of the IOR? Yeah. Part of your prize, yes.
Yeah.
And Owen as well.
Yeah, Paul.
Did you get your membership come through? Your
No.
membership. Have you had £125 tool voucher yet or not?
No.
Okay, I'll chase that up for you because they've got your certificate as well. Okay. Well, yeah, I'll get that sorted out for you. Right. I want to talk to you about membership, the IOR, and IOR membership. So if you look at, say, I think Sean, you should get at least, well, you should get a technician member. You should. Okay.
Right.
Have they said anything to you about what?
Nothing as yet. I need to. I'll message Lisa Jane and say like, what's going on with this?
Yeah.
Because she did email you the other day asking about, did you get your voucher? You've not spent it yet, and I was like, I've just not seen or needed anything.
Okay. Let me just talk about. I want to read about this first because I want to get all of you signed up as student membership. Okay. Now, let's have a look here. Let's have a look. Student membership, free apprenticeship membership. So this is interesting. I think I'll have to have a look at this. It says if you're registered on the RSHP Engineering apprenticeship, we can have a free student membership during your course. So you're not doing that, must admit. So looking at this now, we can apply for you to get student membership, but I have to have a look at that because I'm pretty certain it's free of charge for you. But basically, what it's saying is this grade is designed to encourage those new to the industry to get networking and make valuable contacts within the sector, as well as providing access to useful technical information to support their studies. Students gain access to all IOR technical material and news. Open to undergraduate students and postgraduate researchers. Students are eligible to apply for student membership with the Engineering Council. After a maximum of 3 years, student members are expected to apply to advance to associate or another grade of membership. But it's saying here £33. I'm pretty certain they said because you're on a training program, okay, not necessarily an apprenticeship as such, then I'm going to try and get free for you, free membership of the IOR for you. But what you get as a member, you get access to the master classes, handouts, webinars, any activities they do, and that it's useful. Okay. Now, if I'm looking at Sean, for example, I mean, if I'm looking at the whole membership scenario, this is you got that's a full member, that's associate member, a pre-associate, an affiliate, and technician member. Okay, so basically, student members, people like, for example, Oliver, I know you just got your FCAS. To become a technician, to get technician membership, you need to have your FCAS plus 3 years of experience. Okay, and I know that Sean and probably Gareth fall into that boat on this program. So what we're saying is here, as a technician member, Sean, we're saying
I'm here still.
He said, yeah. Now, IR technician members must have at least 3 years experience in a hands-on role, for example, service and maintenance engineer, and hold a current FCAS certificate qualification. They gain access to regular good practice guidance notes written for service engineers, and receive a quarterly mailing, as well as the usual IOR membership benefits. You can use the initials TMR after your name and apply for engineering technician registration with the Engineering Council. Technicians can vote in elections and stand for election to the Board of Trustees. The IOR can help employers to provide access to technician member benefits for all suitable staff. Contact us for more information. So basically, Sean, I think you should go in. You should be, when you, I do, not now, but starting your application, okay, there's a £63 annual fee, but you can use letters, and that gives you a lot more kudos, and also gives you access to a whole host of library handouts and stuff. Does that sound appealing, Sean?
Sorry, say that again.
Does that sound appealing to you or not?
Yeah, while you were speaking then, I've just gone and got the letter.
Right.
That one.
Okay, yeah, that's
Let me see. There might be a code in here that I've got to type into.
Right, okay.
It says £120 a year for free. The membership should be £120 for the year with the one I've got. As a finance student, you were delighted to offer you membership to Institute of Refrigeration. This will give you full access to our specialist technical information and refrigerant codes, resources, and support of refrigeration. Engineers, this usually costs £120 a year. In addition, to celebrate our 125, you will also be given £125 towards training and development. Please see the contribution below.
All right, we'll have to have a look at. Okay, so what I'm suggesting is that all I need to have, and I've got them already, are your email addresses, which I'll get across to the IOR, and then they'll send you the link so you can actually sign in onto this website. So looking at this website, for example, we have let's have a look at this one. So if we look at technical, these publications, so for example, if you wanted to find out, for example, here it says here, determining the wattage of electric heaters, yeah, electrical safe isolation, and there's a whole host of stuff. Okay, so for example, if I looked at this is useful to everyone, safe isolation, I should be able to. It could. See, they recognise I've not signed in yet, I think. So if I sign in here, I've signed in, and then, for example, if I looked at electrical safe isolation, I can now download it here. Okay. So that's gone up there, and then I can actually open it out. And I'm just want to see if you can actually see my screen. Give it time to load. Okay. So these are the ones these are handouts that you get. So if I'm looking at this, and I do want to discuss this again, just remind you, okay? So this is electrical safe isolation, working dead to stay alive, okay? This guide explains how you should safely isolate electrical equipment prior to working. It is essential you follow this procedure to prevent both electric shock and injuries due to equipment starting up unexpectedly. I'll actually email this to you guys, all right? Because I can actually I've downloaded it and I can forward it on to you. So what I'm saying is, the Electricity at Work Regulations, 1989, Regulation 13, precautions for work on equipment made dead. Adequate precautions shall be taken to prevent electrical equipment which will be made dead in order to prevent danger while working is carried out on or near that equipment from becoming electrically charged during that work if danger may thereby arise. Equipment required.
Paul, can I be excused? My daughter's just called. I'm going to head over to her.
Okay, no worries.
Right. I'll speak to you tomorrow. By the way.
Yeah, okay. Owen, do you carry out safe isolation?
Yep.
Yeah, so what kind of things do you get up to then, please, Owen?
What? In general, like locking off like panels.
Excellent.
Sort of making sure you have the key with you if leaving it unattended.
Okay. Brilliant.
Yeah.
Excellent. No, that's great. What about Liam? Do safe isolate? Liam,
What?
do you carry out safe isolation at the moment?
Do I carry out safe isolation?
Yeah.
Yeah.
So what I'm saying here is that you got the equipment required. You need the following equipment to be able to safely isolate and lock off a supply: isolation padlock and key, multiple worker isolation padlock tag, isolation devices to suit different isolated or MCBs, etc., warning notices, a voltage tester, and a voltage proving unit. Okay, so it does tell you, CHSC GS38. Now, GS38, I harp on about it because that gives you the safety factors that your test meter should have. Things like finger guards and no more than 2 millimeters. Be a probe showing on the end of your test probes. Okay, so safe isolation. Number one, identify the circuit or equipment to be worked on. Check condition of voltage tester and operation against a known voltage supply. Isolate supply and secure isolation. Lock off, multi-lock off if multiple workers. You get to a lock where you can actually put more than one padlock on. So you might have 4 engineers or 4 contractors, and each will have their own padlock with key, and they keep the key on themselves. So if there's four padlocks on, all 4 of you will have to isolate it before it can be switched on for safety. We don't want anybody being electrocuted. Okay. So what we're saying is here is, I identify the circuit or
I
equipment.
don't know why people are asked about getting electrocuted. I get electrocuted all the time.
So why? Why do you get that?
Nah, I've
should
been
be safe.
electrocuted twice, but doesn't even hurt. It was weird.
You should be, try and be a bit more safe.
About 240 volts I go through me.
Ouch. Did you feel it?
Oh, 400 volts would, yeah, but you don't get that.
Oh my
Not on
God.
that stuff.
Okay, I mean, you ought to be glad, tall lad. Okay, and each of us has got separate body resistances, and we can tolerate different amounts of electricity before we die. Before we get electrocuted.
Well, it's the amps that get you, isn't it, Paul?
Correct.
It's not the volts.
Yeah, it is the amp. It's the flow of current that will actually sizzle you or stop your heart from beating, basically. Okay, so isolate supply and secure isolation, lock off with a multi-lock off multiple workers. Prove the tester on a known live source. Test the circuit and then reprove the tester. So what I'm saying there is that if it's a 230 volt supply, your tester has to be proved on a known supply. So you know that supply is working. You test it, so they'll give you a voltage, 230 volts. You know the voltage test is working, so you put it onto the circuit that you've isolated, and you're expecting 0 volts. Okay, and then after you've tested it, you retest it again to prove that the meter is working properly. So you prove the test that's working properly, check for dead, there's no voltage, i.e. 0 volts, and then you check it again on the proving unit to make sure you're still getting 230 volts. So the meter is working properly. So prove the tester on a known live source, test the circuit, and then reprove the tester. Retain key and post caution and danger notices. Take precautions against adjacent live circuit equipment, if any. Issue permit to work and work dead. What does work dead mean?
Work while the power's
You're
on.
dead. Work dead
while the
means
power's
it's
on.
a dead supply. There's no voltage in that circuit. It's dead. 0 volts. Okay, and that's why you're using a proving unit to ensure that when you go across live and neutral, you don't get 230 volts, but you get 0 volts. If you did get 230 volts with the supply isolated, what does that mean? Let's say you've got a situation where you've safely isolated the supply and locked it off, but then you check for dead and there's a supply there, 230 volts.
Yeah, we still got increments from somewhere.
Yeah, you may have isolated the wrong one, the wrong MCB. Yeah, or it's being fed from somewhere else. We normally get that with condensate pumps on aircon. You got your outdoor unit and the indoor unit are interconnected, but then you could have the condensate pump supplied from a fuse spur from somewhere else. Yeah, from another socket somewhere up in the ceiling. So that's why you check for dead to make sure that condensate pump isn't live if you're going to work on it. And that's what working dead means. Yeah, work dead means exactly that. So there's no supply. Here, reinstating supply. Well, ensure all work is complete. Ensure all covers and lids are replaced. Remove lock-off and warning notices. Multi-unlock in multiple workers. Reinstate supply. Turn on equipment locally if possible. And then sign off permit to work. And here you've got the voltages. So what we're saying here is this is a single volt supply, live and neutral and earth. And this is just confirming that, say, between live and earth, you get 230 volts. Okay, 230 volts. Between live and neutral, that's also 230 volts there. However, across neutral and earth, it should be 0 volts. Okay, 0 volts. So sometimes, for example, particularly in a pressure switch, we have no neutral in pressure switches. So what you do is you put one probe onto the earth, the other one onto the live contact, and if you've got 230 volts, it's telling you that pressure switch is live. You're getting supplied to it. It's not broken. Whereas if you go from, say, earth, and you go to live, and you go 0 volts, it means the switch is open circuit. There's no supply there. And that's a good way of checking that the switches are functioning. And so you're checking 230 volts with the supply on that side. On three-phase supply, okay, so you got L1, L2, and L3. You've also got a neutral and an earth. So this is a three-phase, 5-wire supply. Okay, 5 wires because you got L1, L2, L3, neutral and earth. So across phases, okay, so across L1 and L2, you get 400 volts. Across L2 and L3, you get 400 volts. And then across L3 and L1, you'll get 400 volts. However, single phase, from any phase to neutral, so L3 to neutral will be 230 volts. L2 to neutral, that'll be 230 volts also. And L1 to neutral, that'll all be 230 volts. So any phase and neutral, you get 230 volts across it. Okay? And across neutral and earth, it's 0 volts. No voltage there. And the color coding now for cables, brown live, black is live, 3 phase, grey is live, and then blue is neutral, green and yellow is earth. And on a single phase supply, brown is live, blue is neutral, green and yellow is earth. Whereas in the old days, we used to have red and black. Okay, red and black. So these are the new color codes. Not new, they've been around quite some time. So chaps, any questions on that? Will, are you okay with that? I think you're all right, yeah.
Yeah, I haven't got any questions.
Okay, good. Liam, are you okay with this?
Yeah, I'm alright with that.
Brilliant. Declan? Harry?
Yeah, I'm okay with it.
Sound like that, cool.
Jamal?
Yeah, I'm alright with it.
Excellent. Sam, how are you with this?
Don't know, to be fair.
Okay, it is hard stuff. We'll do more of it. Adnan?
Yeah, it makes sense when you're reading it, but I probably do need to go over it a few times.
Yeah, when we're in the workshop next on Saturday, we'll have a look at bits and pieces on that as well also. And Oliver?
Yeah, I think I'm alright with that, Paul.
Okay, great stuff. All right, what I will do, I've downloaded this handout, and I will actually file. I'm just going to, in fact, I can do that later. Right, I will email that. I'll email that handout to you. Okay, right. Right, let me just get this. Chaps, I'm still chasing job write-ups. I'm honest. I know Jamal sent me some. Thank you, Jamal, on that.
Yeah, no.
I'll have a look at those. Okay. Mm-hmm. It's on that one. Save that one. In fact, I'm going to file save as, so we can add to that. Yeah. I just want to have a look at this, okay? And this is it's a self-test basically, but it's looking at electrical knowledge for RIC and HP systems. Okay. So this good practice guide looks at the range of electrical knowledge that technicians should have related to RIC and HP system fault finding and testing. It is based on the knowledge competence areas and the System Rules Unit 207 electrical systems or RIC HP systems, which is part of the System Rules 7189 Level 2. Especially the diploma in refrigeration, air conditioning, and heat pump systems. Is your knowledge up to date? Do you know all the required fundamentals? This bulletin provides a self-assessment checklist of the basic areas of electrical knowledge and practice that RICHP technicians should be confident in when testing and fault finding on small systems. If you are fully conversant with all of these areas of knowledge and use these skills regularly, then you can tick all the boxes. Although this list is not comprehensive and you will need more specific knowledge for the type of equipment you are working on and should always carry out a risk assessment prior to commencement of work. If there are some areas that you would like to brush up on, you can consult the list of useful resources overlay or contact your training provider for information about refrigeration electrics courses near you, i.e. me or others. Okay, so what I'm saying is these are the kind of things that you need to be aware of. Okay, and I'm going to be making a mental note or discussing what these things are just to make sure. Okay, right. So number one, health and safety. Are you familiar with current health and safety legislation? For example, electricity at work regulations as well. So health and safety you should be aware of. The electricity at work regulation basically means that you should be not working with you shouldn't be working on live equipment if you can help it. You should always be working dead. Okay. How have you certified this knowledge? Now, at the moment, those doing the diploma, there's electrical qualification unit on electrical, the 207 electrical theory and practical. For the NVQ, even though you guys are doing, like, for example, Owen, Liam, Jamal, Declan, Harry, you're doing a level 2 NVQ. The electrical in the NVQ, it's a level 3 unit. Okay, it's quite complex unit. Okay, which I want to get into rather sooner than later. And it is a level 3 NVQ unit. Also, you've got some electrical tests, electrical wiring to do. So, for example, everyone doing the diploma and doing the NVQ, you got to pipe up the cold room per se. That's piping up the condensing unit, the evaporator with all the interconnecting pipe work, dryer, sight glass, solenoid valve, TV, evaporator, suction line back to the compressor, 5/8 and 3/8 pipe work, incorporating braze joint and sulfur joints. And then you've got a pressure test to the standards, evacuate and recharge. Also, you've got to do the wiring for it. You've got to do the wiring for the controller. You've got to wire up the solenoid valve, the evaporator fans, the LP and HP switches, condenser fans, defrost heaters, and all of them. Okay, that's part of the assessments, and these kind of things are really allowing me to see what you do know, what you don't know, albeit on an individual basis. So the kinds of things we will be covering is things like Ohm's law. Now you should know Ohm's law. For example, voltage, current, resistance, they all tie together. Okay. Direct current and alternating current. So alternating current, where do we get alternating current, guys? Or where is alternating current? Any thoughts? Well, let me tell you. When you put in your socket, you plug into the socket, your main supply, 230 volts, that is an alternating current, AC. That means it's fluctuating, up and down, positive and negative, positive and negative, positive and negative, 50 times per second. Okay, that's alternating current. Direct current is what you get from a battery. Your AA battery, your AAA batteries, your car battery as well. That's direct current. Okay, so it's just basically flowing in one direction. It doesn't go positive and negative. It's just positive to negative on that one there. So potential difference. Anybody tell me what's another word for potential difference? Okay, potential difference is another word for voltage. Okay, it's same as voltage. So if you got 230 volt supply, then that 230 volt supply is really a potential difference of 230 between live and neutral. So potential is voltage difference. So it's voltage. Resistance. Yeah, the resistance of that opposes the current flow and is measured in ohms. And if you got, for example, a solenoid coil, that might have 1200 ohms, 1.2 kilo ohms as resistance. Okay, so you're measuring resistance, and you're measuring the resistance with an ohm meter with the supply off. Yeah, with a live and neutral off. Capacitance, who's heard of capacitors? Capacitors?
Yeah, this is a good place for me to step in. We've had two go on two circuits recently.
Okay.
They store energy and then release it to start a compressor or something that needs a big energy surge.
Excellent, thank you. So what we're saying, a capacitance is a bit like an energy storage, and it gives a boost. It gives like a kick start, like oomph. So in compressors, we have start capacitors and run capacitors. They store energy to give the compressor extra torque to start with, like a big.
Just while we're on this, Paul,
Sorry?
what would be the reason for the two capacitors going?
You could have the situation where you've had a surge in currents,
And what would that be caused by?
or you've got something shorted out, and that's consumed a lot of high current than what was expected. They normally blow on either high voltage or high current going through them.
Okay, because
You go short somewhere.
we've had one blow the top and melt all the wires inside of a fridge.
Not pleasant, I must admit. And usually that's as a result of having too much voltage going through it, or across it, or too much current flowing through it. Either way, they've been overheated. Okay. So capacitance.
So it couldn't be due to overuse of the capacitor.
Sorry.
It couldn't be due to overuse of the capacitor.
No, technically, it was. What could happen to what? Depending on the circuit, the capacitor is either in circuit permanently, which is a low capacitance value. But if it's like a starting capacitor for the motor, and if you don't disconnect that start capacitor within 30 seconds, it's going to blow up. It's not geared to have a high, have voltage going through all the time. It's got to be disconnected. It's only a short boost. Otherwise, if it's permanently in circuit, it's charging and charging and charging and charging. It's not like as if it's got a pressure switch that's going to cut out. It's just going to charge till eventually it'll melt, blow up. Okay.
Just clearing that up, Paul.
Thanks. Okay, my pleasure. And we in our field we use them on compressors. So, for example, if you've got an air conditioning compressor, across the start and run winding, you have a small run capacitor, probably about 4 or 5 microfarads, and that's just to start the compressor on a hermetic compressor on the aircon unit. Okay. All condenser fans have capacitors as well. What I think, we can look at all those. I'll get some more information on those. In fact, frequency. Okay, now frequency is really how the electricity is being generated and flowing. For example, if you look at a 230 AC supply, the AC stands for alternating current, and then you normally got 50 hertz, which basically means the way we're going live and neutral, live and neutral, live and neutral, as we're going through, like that, sine wave, and it's doing 50 cycles per second. Now, if you got 50 cycles per second, 1 cycle per second is a hertz. That's the same that's like the car rental people, HERTZ, hertz. So 50 hertz means 50 cycles per second on the AC. So it's going positive, negative, positive, negative, positive, negative, positive, negative for 50 cycles every second, very, very fast. Okay, and that's the frequency. It's measured in hertz, HERTZ, or the abbreviation is HZ. Okay, impedance. Now, impedance is another word for resistance, really. Okay, it impedes the flow of currents, that's restricting it. Albeit that's when we're looking at impedance, we're looking at main supply coming in and going around the building. Okay, electricians use that more and more. Impedance. It's still measured in ohms, though. Okay, it's still measured in ohms. It impedes the flow of currents. Currents, we know, as Owen said, it's the current that'll kill you, the milliamps, and current is measured in amps, amperes. Okay. Power. Now, power is kilowatts or watts. 1 watt, that's WATT, is 1 joule per second. Okay, so 1 kilowatt is 1,000 joules per second. Okay, electric flow. And if you got a 10 kilowatt motor, it's going to consume 10 kilowatts of power. Okay, we can look at some calculations on that. Okay, electrical shock potential and its consequences. So, Liam, bit of experience? When was the last shock you had, and how? That's Liam, sorry. Liam, you there? Okay, right. So I'm just going to.
Have you ever received a shock yourself, Paul?
Sorry?
Have you ever received a shock yourself?
Yeah, some students give me shocks.
Fair enough.
No, I haven't. I must admit. No, I haven't. Fortunately, I think, no, personally, I can't even remember the last time I had a shock, thankfully. No, I wouldn't want to impose that on anybody, to be honest. Okay, so we're here. That's it. Okay. So what we're saying is electrical shock potential. So basically, if you get, you don't want to touch live and neutral. You could die, and it's the milliamps that will kill you. The flow through your body, going through your heart, could actually render, have dire consequences. Single phase, okay, single phase, that's live and neutral, 230 volt supply, okay, with an earth. Then earthing and bonding. Now, earthing is a safe conductor. So every metal component has to be earthed, and it's usually a green and yellow cable, okay? And it has to be earthed. If you look at your 3-pin plug, the top terminal is your earth, and when you plug it in, it's connected via the socket, earth coming into the house or into the premises, okay? And that's for safety. If there's electric shock, then the earth cable is the cable that actually takes the fault current. It stops you from having a shock, because your body resistance might be, 1200 ohms, okay? However, if your body is wet, then your body is going to be you'll have less resistance. So it's more susceptible to a shock. Whereas the earth cable, it's always rated at a resistance of 1 ohm. Okay, 1 ohm. So from your incoming supply to wherever, no matter however distant you are on your unit, then the resistance has to be less than 1 ohm. Okay, because it has to be one ohm or less, because that will be the least resistance in the circuit. And if there is a fault to earth, any fault, so let's say imagine live touches earth, then the fault current will go through the earth conductor, because they've got low resistance as opposed to your body. Yeah, your body might have a resistance of 1200 ohms, for example, depending on your body mass and stuff. But your earth conductor is always 1 ohm or less. Yeah, 1 ohm or less. And that's all around the build, all around the unit. Bonding, okay, is where you got the earth cable and you strap it to the pipework. And that could be the air conditioning pipe work, the refrigeration pipe work, or it could be to a water pipe or a gas pipe for bonding, to make sure that everything's earthed in case of a fault. Okay, and that's bonding. And we get bonding clamps that we have to use, which are connected to earth via the green and yellow insulated cable. And then if we're looking at series and parallel, for example, if you got let me just stop that. Get back into that. Okay, so what I was saying is that, for example, if you got two condenser fan motors and you want them to run at the same time, are they wired in parallel with each other or in series with each other?
Parallel.
Parallel. So they're wired across live and neutral. Okay, so they each receive the 230 volts. Okay, whereas if you got, let's say you got two pressure switches, you got low pressure switch and a high pressure switch, they have to be wired in series Okay, so they're breaking the live. So LP switch is connected in series to the HP switch, which might be connected to the condenser fan motor and the compressor, and they'll be in parallel. But the switches themselves are in series. So both switches have to be made for that compressor and the condenser fan to operate. And if either switch open circuits, the circuit stops. Okay, that's why you have series switching. So your control circuit, we'll look at some diagrams next time. Okay, but so load equipment like solenoid valves, condenser fans, defrost heaters, they must be connected in parallel across live and neutral. Okay? Whereas switches, they're usually in parallel with each other and in series with the components. So your LPHV, your thermostat, they're all wired into the same live before they go on to controlling the compressor or contactor coil. Okay. Do you understand the working principles of electrical controls? Things like pressure switches, thermostats, flow switches. I'll get into that next time. Okay. And things like motors, resistance by induction. What I would do, I think what I am going to do, is I'm going to email this to everyone later, so you can all have a copy of this, and that's the kind of things you as engineers should have knowledge and competence in. And as we go through, I'll be picking up a lot of stuff on that to aid with your electrical knowledge and then your skill practice as well. Okay, right. Okay, what I want to do is I want to stop now. Okay, it's nearly 8:30. Right. Will, you're doing the diploma, yeah? So you don't have to do any job writers as such. Yeah, so I'll keep tabs on you. Darren has, because he's doing his MVQ. Oliver, you don't need to do anything at the moment. Adnan, you don't either. But people like Sam's still his age yet, but people like Declan, Harry, Jamal, Owen, Liam, you should be doing job write-ups. I know, Liam, I've got to show you how to access the templates. Are you, Owen? Have you, Bubbly? I'm teaching it to my wife, shouting at my children. Sorry. Yeah, I'll have a session on job write-up using the templates as well. But I would urge you to get access to laptops or computers if you haven't already done so. You're not going to do job write-ups on your mobile phones. You're going to be struggling. Really are, because you won't be able to see it. I think Declan had a go on his mobile phone, Declan.
Nah, I weren't able to do it on the phone, so I've always had to try and access a computer before I got the laptop.
It's not, So
I had to go at it.
Hard work.
When I come in once, Paul, on a Friday, I had to go on my phone before and it didn't work.
Yeah, I'm going to touch base with Dave and Faisal about trying to get that sorted out. Otherwise, you're not going to do job write-ups. You're not going to pass. Simple as that.
Yeah, when was it? You said next coming in on a Friday.
I'll get some dates to you. I think it might be in a couple of weeks' time, actually. Looking at my diary now. I want to try and get you definitely booked in for the new year, but we've got 2 or 3 weeks yet before we finish.
Yeah.
I'd like to either come over to your place with all 3 of you at the office with Faisal and David. Not to have a go at you, but just to see if there's access to the computers there.
Yeah.
So I can support you on that. And if not, we'll have to look at plan B. And the plan B will have to be, try and do them at my place somehow. All right.
Yeah.
Again, also NVQ lads, people like Owen, Liam, on-site assessments I'll be looking at with a view to making on-site assessment, whether you're no matter where you are, Manchester, Bristol, Northampton, I'll come out to site and observe you doing bits and pieces on that. Okay, I'd like to try and do some before Christmas if I can, but I'll keep in contact with you. I want to keep more regular contact with you individually as well. And I've been ringing a couple of people, a few people, just to see how they're doing on that. Adnan, you're in on Saturday, yeah? All right.
Yeah.
All right, guys. I'll see you next week, yeah?
Yeah, see you next week, Paul.
Right, cheers, guys. It's getting a bit noisy here. I'll have to have a chat with my wife. All right. Good night. See you guys. Thank you for that. Cheers. Thanks.